This video is about z-scores and confidence intervals. The average on the tests in my class and Mrs. Merrill's class were normally distributed on the last advanced algebra test we gave. The average in my class was 86 with a standard deviation of 3. The average of Mrs. Merrill's class was 82 with a standard deviation of 4. You made an 88 on my test, and your friend made an 85 on Merrill's test. Who had the better score in comparison to the rest of their class? Well, I've highlighted the numbers that pertain to you. So let's calculate your z-score using the class average, the standard deviation, and your score. Alright, so there you go. And that's going to give you a z-score of 0.67. Now again, remember that the formula for z-score is a certain value minus the mean divided by the standard deviation. So, if we're going to do your friend's z-score, these are the three values we're going to need: the class average, the standard deviation, and your friend's score. Okay, so there we have it set up, and that gives your friend a z-score of 0.75. So obviously your friend did better compared to her class. Alright, because she has the higher z-score. Specifically, she did 0.75 standard deviations above her class average, whereas you only did 0.67 standard deviations above your class average. Number 13. To estimate M, the mean salary of full professors at American colleges and universities, you obtain the salaries of a random sample of 400 full professors. The mean sample, the sample mean, is 73,220, and the sample standard deviation is 4,400. For part A here, we're supposed to find the 95% confidence interval for the above data. Alright, as soon as they mention a 95% confidence interval, you know we're going to have to use this formula for margin of error, right? As opposed to this old formula, which has nothing to do with specific levels of confidence. Alright, because if we want the 95% confidence level, we need to get this z-score of 1.96 involved. Alright, so let's start by calculating this margin of error using this formula. By the way, we've got our z-score, this is standard deviation, and square root of the sample size. Alright, so here is the setup for the margin of error: the z-score, the standard deviation, the sample size. Just put that in your calculator. Now, when we build the confidence interval, we start with whatever the sample mean was. So the sample was 73,220. And what we're going to do is we're going to add and subtract the margin of error. So first we will subtract the margin of error. Alright, that's supposed to be a comma. And then we will add the margin of error. And that's how we will get our confidence interval. So if I put this in my calculator, it's going to look like this. So that gives me 431.2. Alright, so this is how we get the confidence interval. So there is the confidence interval. So this was a 95% confidence interval, so we can be 95% sure that the real average salary of all the professors is somewhere within this range. For the 99% confidence interval, we're going to do the same exact thing, except for instead of 1.96, we're going to need a z-score of 2.575. That's going to look like this in the calculator, and we get 566.5. Alright, so this will give us the confidence interval. Alright, so there's our 99% confidence interval. Last week, one of my students asked me, well, why don't we always just use the 99%? Isn't it better to be more confident? Well, you're losing something when you go to a higher confidence level. You have a wider range, a wider interval. So the 95% confidence interval is a smaller, more precise interval. So to get the additional confidence, we had to widen that up, get a little bit more imprecise. So so either way, you lose something. You're either losing confidence or you're losing accuracy. So you just have to decide whether you want to be more sure that the truth is in there somewhere, or if you want the interval that you have to be more accurate. For number 14, we are going to find the sample size required to achieve a margin of error of plus or minus 4.56. Now, notice this time we're talking about margin of error, but they are not saying anything about 95% confidence level or 99% confidence level. That is important, because if they don't mention a confidence level, then we are not going to use this margin of error formula. Instead, we're going to use this more basic margin of error formula. That's just 1 over the square root of n. Let me zoom. Alright, so first of all, remember, we're using the formula that goes like this. The margin of error is 1 over the square root of the sample size. Now, we need to have this as a decimal to plug into this formula. So if I move the decimal twice to the left, I've got 0.0456. Alright, so that's my margin of error. So I'm going to put that right here. So I've got 0.0456 equals 1 over the square root of the sample size. Alright, now we've learned that we can always swap these two things. Alright, so that's going to give us the square root of n is equal to 1 over 0.0456. Now to unsquare this thing, we need to square both sides of this equation. Alright, so if I do that, then that's going to give me n equals. So I'm just going to put this in the calculator. Alright, I'm getting 480.92. Now for sample size, we will round this to the nearest whole number. So this will be 481. Alright, that's the sample size that would be needed to get this margin of error. Alright, so that was number 14. Alright, an airline finds that travel time between two cities has a mean of 85 minutes and a standard deviation of 7 minutes. So let's find a z-score for a travel time of 75 minutes. Alright, well look, the formula for z-score is like this. It's the z-score is equal to a value minus the mean divided by the standard deviation. So if we're talking about a 75-minute flight, then 75 is the value minus the mean of 85, alright, divided by a standard deviation of 7. So that's giving us a z-score of negative 1.43. Let's do the same thing for 90-minute travel time for part B. Alright, so that would mean 90 minus 85 divided by 7. Alright, I'm getting z equals 0.71 for that one. Okay, what does this tell you about the two flights above? Well, these numbers tell us that the 75-minute flight is 1.43 standard deviations below the mean flight length, and the 90-minute flight is 0.71 standard deviations above the mean flight length. Find the travel time that gives you a z-score of 0.312. Find the travel time. Okay, so they're giving us a z-score, so that's going to go first. So, I'm sorry, it's not point anything, it's 3.12. Alright, so looking at our formula, it's going to be the value minus the mean, which is still 85, divided by the standard deviation. So to solve this, we will just multiply both sides by 7. So these are going to cancel out. So that gives us 21.84 is equal to x minus 85. Next, we will add 85 to both sides. Alright, and that is going to give us x is equal to 106.84. And I should add in minutes. Okay, so that's the travel time that would have this z-score, which is more than 3 standard deviations above the mean. Okay, the National Collegiate Athletic Association, NCAA, requires Division I athletes to score at least 820 on the combined mathematics and verbal parts of the SAT exam in order to compete in their first college year. Higher scores are required for students with poor high school grades. In 1999, that was a long time ago, the scores of the millions of students taking the SATs were approximately normal, with a mean of 1,017 and a standard deviation of 209. What percent of all students had scores less than 820? Well, I'm going to solve this using the box method. So if I were you, I would just draw my own box. If you need to do this on your own paper and staple it, then do what you got to do, because organizing your work will help you nail this and do it perfectly. So in the first box, I'm going to do a nice bell curve. Well, I say a nice bell curve. I'm going to do my best. That's about as good as I can do. And what are we talking about? We're talking about SAT scores. Alright, so SAT scores. Alright, so we'll put the mean in the middle. So what do they say? Mean of 1,017. So here I go. 1,017 goes right there. And we want to know what percent of all students had scores less than 820. Okay, so 820 is clearly below this. So I'm going to put my 820 over here someplace. 820. So I want to know what percent was less than this. So I'm going to shade over here. Okay, because this is the area I want to know about. Okay. To figure this out, I'm going to need to change this into a z-score, and I'm going to wind up graphing that. So let's do that. So if I want to find a z-score for this value, I'm going to do the formula. So I'm going to do 820 minus the mean divided by the standard deviation, 209. Okay. So that will give me the z-score of this. I'm just going to do that in my calculator. Alright, I'm getting this z-score of negative 0.94. Alright, so that's almost 1 standard deviation below the mean. But I'm going to be more precise than that. So let's go ahead and make a percentage statement right now. We're looking for the percentage of z-scores that are less than negative 0.94. Okay, let's go ahead and do our z-score graph. Maybe I'll cheat and cut and paste a little bit. Maybe I'll just cut and paste all of it. Okay, so this is a z-score of negative 0.94. On a z-score graph, the mean is always 0. And we will label this as z-scores. Okay, so we're looking for these percentages. Here's where we use our z-score table. So we need to find a z-score of negative 0.94 on a table like this. So start with the first 2 digits. We're looking for negative 0.9. Alright, don't worry about the 4 yet. So negative 0.9 is right here. So that tells us that we're at the right row. Now we need the 4 next. So I don't know if I can see this at the top or not. It's way up here. So here's the 4 column. Notice that the first column is 0. So this is 0, 1, 2, 3, 4. So this is the number I want. As a percentage, this is 17.36%. Okay, by the way, as you can see in the little diagram, if I can show it to you, see this little diagram? See how it's shaded to the left of the z-value? These percentages are all percentages to the left of any given z-value. So if I need a value that's to the left, which I did, then I can just read these numbers right off the graph, like I did, right off the chart. But if I ever needed a value that was to the right of a z-score, I would have to subtract this from 100 to get the right-hand side. So just bear that in mind. Anyway, let's include this information on our picture. Okay, so this over here, this shaded area represents 17.36% of the students. 17.36%. And let's go ahead and write our final answer in the form of a sentence. Okay, which is what the 4th box is for. 17.36% of the students scored below 820. Alright, so that's it for that problem. Now for part B, we're supposed to find out what percent of all students had scores between 800 and 1,200. Alright, I'm going to use the box method again. So there's not a lot of space here, so if I were you, I would do this on a separate sheet of paper and attach it. And that's what I would do on a test as well, if you're not given a box or enough space to draw a box. Okay, so here I go again. Alright, so my 2 bell curves are all ready to go. Now, the mean is not changing, so I'm still talking about a mean of 1,017. We're still talking about SAT scores. And down here, we are still talking about z-scores, of which the mean is always 0. So, between 800 and 1,200. So, let's see. 800 is going to be somewhere over here to the left. Alright, so let me put that down. And 1,200 is going to be somewhere over here to the right. Alright, so if I want the percent that's between here, then that's where I'm going to shade in my diagram. Okay, so that's what I'm looking for. Alright, so I've got two z-scores I'm going to need to calculate. So my first z-score is going to come from the 800. So I'm going to do 800 minus the 1017 divided by the standard deviation, which was 209. Okay, so that's going to give me one of my z-scores. You know what, maybe I'll just put it underneath to leave space for the other. Okay, because there's more I have to do this time. Alright, anyway, I'm going to just put this in my calculator. Alright, I'm getting negative 1.04 for that one. And I'm going to have to do the same thing again with the 1200. So I'm going to do 1200 minus the 1017 divided by 209. Okay, I had 0.87559 blah blah blah. That's going to round to two decimal places, 0.88. Okay, so I need to find the percentages associated with each of these. If, well, I can go ahead and show this on my z-score graph now. Okay, so this one over here is my negative 1.04, and this one over here is my 0.88. And we are going between. Alright, so I need to find these scores on the z-score chart. Anytime you want to find the percentage of data that's between two z-scores, here's how you're going to set it up, and you have to show this work. The percentage of z-scores between these two numbers, I'm going to say negative 1.04 is less than z, which is less than 0.88. Okay, that's how you do it. Now the way you actually calculate it is we're going to find these percentages on the chart and we will always subtract. So when you're doing between, you're always going to subtract the big minus the small. So we're going to start with the 0.88. Okay, and again, start with the 0.8 part. So let's see, this is positive, so here I go. I see 0.8 is right here, and then it's 0.88. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 81.06. Okay, I'm going to subtract. So now I need to find negative 1.04. Focus on the negative 1.0. Okay, I feel like I'm going to erase these so they're out of my sight. So here's my negative 1.0. Now it was negative 1.04. So this is column 0, 1, 2, 3, 4. So this is the 1. So that is 14.92%. Alright, so we're just going to subtract these to get the final answer. Maybe I'll change colors so you can see it better. Alright, but I'm just subtracting these two in my calculator. Alright, I'm coming up with 66.14%. Okay, so that's what we have here, 66.14%. 66.14%. So let's put our final answer into words in the last box. So there you go, 66.14% of the students scored between 800 and 1,200. Alright, last question. What percent of all students had scores greater than 1,400? So one more time, I'm going to do the box method. So again, I encourage you to take out another sheet of paper and do it up right if they didn't give you enough space. I am going to do a little bit of cutting and pasting, save myself some time and effort. Don't judge me. Okay, so up here we are still doing SAT scores. Down here we are still doing Z-scores. The mean Z-score is always 0. And the mean SAT score for this problem was 1,017. Now we want to know what percent of all students had a score greater than 1,400. So that's clearly going to be over here to the right somewhere. Okay, so I'm just going to put it over here somewhere. Okay, so 1,400. We want to know the percentage that is greater than this, so that's why I'm going to shade over here to the right, because that's the part I need to know about. Okay, so we're going to need the Z-score. So here we go. So the Z-score is going to be this 1,400 minus the mean divided by the standard deviation, which we were told way back at the beginning was 209. Okay, so just put that in your calculator. Alright, I'm getting 1.83. Alright, so I can go ahead and include that, 1.83. By the way, for these, always do 2 decimal places because that's what I have on my chart. So let's start with the 1.8 part. Okay, so that's on the positive side. So here's my 1.8 right here. Alright, and this is 0, 1, 2, 3. So this is the number I look at. It's 1.8, remember, is 1.83. The 1.8 tells me the row, the 3 tells me the column. So this is 96.64%. However, be careful. I am not going to just write down 96.64%. Oh no. If I want the probability of Z-scores that are greater than 1.83, okay, the reality is 96.64%, that's the percentage of scores that are over here on the left. Okay, 96.64% is over here. If I want the Z-scores that are over here to the right, I need to subtract from 100. Alright, clearly this is going to be something less, a lot less than 96.64%. Look how tiny it is. Okay, this is 50% right here. So you know if you get a number bigger than 50% and you're looking at an area that's less than half, you missed an opportunity to subtract from 100. So just remember that. So we're going to do 100% minus this 96.64%. And that's what you always have to do anytime it's to the right like this. Okay, so just put that in your calculator. So there's the number that we want, 3.36%. Alright, a very low percentage indeed. These are the best of the best students on the SAT. Okay, so that's what this number is over here. So we've got our 3.36% of students above this Z-score. So that's the same thing here. 3.36% of the students are above 1400. All right? Anyway, let's go ahead and record our final answer as a sentence. So we would say 3.36% of the students scored above 1,400.